I do not have any financial interest to disclose. Phacoemulsification is facing its biggest challenge ever, conquering the rock-hard brunescent nuclei. The grading system of cataract is probably unable to predict the hardness, thickness, and leatheriness of these cataracts. Dividing these more harder brown nuclei safely in phacoemulsification is the final hurdle to cross. Direct chopping in a thick, full, hard nucleus often fails to divide the nucleus completely. Excavating a central crater at the core of the nucleus first and then initiating a direct chopping is a better option in these situations. Central debulking provides a space for good hold on the nucleus as well as reduces thickness in central part. Ideally, the central crater must be small and deep so as to help to hold the nucleus in paracentral region. Holding in more peripheral parts during chopping will fail to crack the posterior plate centrally. But even this technique is not adequate and safe all the time. Completing the crack on the nucleus extending posteriorly involving the posterior plate often generates undue, unwanted pressure over the jonular bag complex, resulting in complications like jonular dialysis or more catastrophic endpoints. Attempting fragments removal without complete separation of the nucleus segments may further enhance the risk factors. Use of standard Kelman tips create an inadequate depth central crater. To produce the deepest central crater, the force has to be applied perpendicular to the nucleus surface as the power-driven drill creates on the wall here. I need something which can be put perpendicularly over the central nucleus surface, at the same time not causing any injury on the corneal endothelium. I also need something that will bore through these nuclei, falling short of the posterior capsule by quite a safe margin. A bend in the exposed phaco tip, if increased to 90 degree in the form of the letter L, can probably be my answer. Wet lab analysis of more than 500 brunescent nuclei collected through manual cataract surgeries done at our peripheral centers allowed us to quantify the central thickness of these nuclei. Average central thickness measured was more than 3.5 mm, and accordingly, the bioengineering division of our hospital modeled the phaco L tip with the length of the bent arm on its outer side about 2.5 mm. On the inner side, it's 0.9 mm less. Tested on the wet lab nuclei, the tip showed excellent central deep penetration. An excellent central deep crater with enough safe margin posteriorly even at its fullest penetration. Now to put the experimental results to the hardcore reality. Internal hospital board approval was taken and the phaco L tip was used in live surgery to initiate the first central boring. Just like the power-driven drill against the wall, the tip held perpendicular to the central nucleus surface, cut easily through the substance, producing at least a 2 mm deep crater. The L tip was then changed with standard Kelman tip and phacoemulsification was continued with direct chopping. Standard technique of vertical chopping followed. Chopper was gradually introduced deeper and deeper into the nucleus substance and separation force was applied till posterior plate cracked completely. Sometimes the phaco tip also changed position on the nuclear plane for a better hold, going further down. The centrally debulked nucleus was easier to hold in mid-peripheral area and chopped with complete cracking of the posterior plate with much less tension on the jonular bag complex. L-tip also produced a much less acute angle with the corneal wound compared to the standard phaco tips, thereby reducing wound tension as well. A single punch with L-tip at the center of the nucleus changed its status from unbreakable to breakable. The phaco L-tip, added with the torsional power of Uzil, cut through the nucleus substance exactly like the motor-driven drill. The bore widens as the tip goes deeper. The crater is uniformly deep compared to the crater made by standard Kelman tips, which tends to be more wide but shallower. Each and every case with this innovation showed less phaco power, less effective phaco time, and faster surgical time without any dreadful complication. The complete division of the posterior plate even in the hardest cataracts was a sure and safe endpoint with this simple innovative remodeling of the phaco tip each and every time. As we have experienced in more than 400 cases since 2010. We advocate this L-tip for Brunnesen cataracts only.